everyone. Welcome to the video lecture series in probability. I am Professor Mayur Gohil. In this video lecture, I shall be discussing the problem that you see on your screen, that is a continuous random variable is given to us, okay, which is having the following PDF: f of x equals to k times x square into e to the power minus x, where it is defined from the interval 0 less than x, less than or equal to x, and 0 elsewhere. And we have to find k, the mean of x and variance of x. First of all, I would like to tell you that this is a very standard question asked in most of the exams where a random variable or probability is the topic of concern, okay, or statistics or mathematics, wherever this topic is being taught, this is one of the very standard questions that is asked in most of the examinations. So it is very important that by this time the student must have learned substantial amount of mathematics and concepts of integration. Then it is a good thing to solve this problem in a very easy manner. Okay, so let us do this question, and I hope you will benefit from this solution as well, because I'll be showing you two types of solution, in one basic method and the other one as an advanced way, where you will be really surprised if you know a bit of advanced formulas. This things boils down very easily to a very simple answer. So let us see how to handle this. The first of all, what we are given is x is a continuous random variable. So we write down that information. Alright, now what is it given to us is this number line. On number line from minus infinity to infinity, if we put up 0 over here, the PDF is rather very well defined for 0 to infinity, right? Because upper limit of x is not given, that means the limit is infinity, and other places, that means from minus infinity to 0 it is 0. So the over here it is 0, but here it is kx square e raised to minus x. That is what is the definition of your PDF over here. So now we use the property that because x is a continuous variable, over here we will use the property that PDF always has from minus infinity to infinity. If you integrate the PDF, it gives you 1. Okay, the integration is 1. So now we can integrate here from 0 to infinity k times x square into e raised to minus x dx. Once we perform this integration, let us see how to handle it. So k times integration 0 to infinity x square into e raised to minus x dx equals to 1. That is what we will get. And now we see that over here we can perform the integration. So when we perform the integration, be little bit careful, as the k is already outside, and we'll go slowly with the integration here. So it is x square into e raised to minus x over minus 1 minus times 2x into e raised to minus x over minus 1 square, and then there is plus 2 times, here it will be e raised to minus x over minus 1 the whole cube. Now this is one of the advanced formulas of UV rule that one needs to know. Now once we do this UV rule, we plug up the limits. So what we get here is k times, now whenever we plug up the upper limit to all those terms where is e raised to minus x is there, what will happen is the answer is gonna go 0. Okay, so here it's for the first term, when you plug up the limit infinity, it's going to give you 0, and later on when you put the minus sign for the lower limit as per the formula, and then you put 0 wherever x is concerned. It's gonna give you 0. So it is finally the answer is 2 into minus 1 here, and that is equals to 1. So here you get k times 2 is 1. So what we get is k is equals to half. That is the required value of k. Now once we have the required value of k, okay, we will write down the required PDF. So that is the PDF we will be now focusing on. So required PDF will be f of x with half times x square into e raised to minus x, where 0 less than equals to x. You can put less than infinity as a you know extra part, but it's okay if you do not put infinity there. And then here it is, otherwise it is 0. So this is the required PDF for x. Okay, so this is what we get now. Now it is on this PDF that we will go and calculate for the mean. So let us calculate for the mean. So the second portion that is asked is to find mean. So let us see mean of x, right? So the formula over here is e of x is equals to minus infinity to infinity x times f of x dx. This is the formula. Now when you substitute the value of your PDF, it is defined from 0 to infinity. So x times half into x square into e raised to minus x dx we have to calculate. Now this gives me the value here, it is half times 0 to infinity x cube, it will become e raised to minus x dx. Now you can see it is little going to go a little bit longer, but yeah, this is the way. If you do not know the advanced formula, you need to struggle with the integration and get the whole integration solved. So half times, it's gonna go for x cube e raised to minus x over minus 1, and then it is 3 times x square. Do the derivative of x cube, then it is e raised to minus x over minus 1. Okay, so here, and then it is plus 6x e raised to, yeah, here it's minus 1 square e raised to minus x over minus 1 the whole cube, and then there is minus 6 into e raised to minus x over minus 1 whole raised to 4. Okay, you plug up the limits from 0 to infinity. On further solving of this, you get half is outside. Okay, and wherever, again the same logic is applied, wherever you see the infinity, okay, e raised to minus x, if you see there, and wherever you put the infinity, it's gonna go down to 0. So that's 0 there, and wherever x's are involved, the lower limit when you plug up, it's going to give you 0. But at the last term, there is minus 6 staying there, so it's minus 6, and here the final answer will be 6 over 2, that is 3. So you have your expectation of x as 3. That's the calculation of the mean of x. So this is the mean of x. Now let's go for calculation of variance of x also. I'll just put this in box. Now for calculation of variance, so variance of x is given by the formula v of x, it's the notation, and the formula is e of x square minus e of x the whole square. Okay, that's the way it is calculated. There's the formula, the simplified version. So let us calculate e of x square. So therefore e of x square, when we have to calculate, we will first do the formula as the ritual is. So x square into f of x dx, and now when you plug up the limits of the PDF, it is from 0 to infinity x squared times half into x squared into e raised to minus x dx. So this becomes half into 0 to infinity x raised to 4 into e raised to minus x dx. So this is going to be half times x raised to 4 into e raised to minus x over minus 1. Then it is plus, minus, and here there is 4x cube. Do the derivative of x raised to 4, integrate e raised to minus x twice, so you get e raised to minus x over minus 1 the whole square, and then again you do the derivative of 4x cube. That's gonna give you 12x. Okay, and then there is e raised to minus x over minus 1 cube, and then minus times it's 12x square here, and then it is 24x, and then e raised to minus x over minus 1 whole raised to 4. Okay, and then you have plus 24 times e raised to minus x into minus 1 whole raised to 5. Okay, that's the whole big number there. It's a big expression. So when you substitute again the upper limit, it becomes e raised to x times half into 0, okay, minus, and all the terms having x's are gonna go down to 0. Okay, and what will happen later on, because when you substitute the 0 number for the 24 into e raised to minus x over minus 1 raised to 5, you will get here it is 0 minus of 24 you will get, and so this final answer will be 12 or e raised to x square. Okay, and 12 over 2, so e raised to x square, oh sorry, not 12 over 2, it's, you will get the value of e raised to x square as 24 divided by 2, which is 12. So e raised to x square is 12. So finally, therefore, variance of x is v of x, which is equals to e of x square minus e of x the whole square. I know I'm repeating the formula so that it is there in your mind again, and 12 minus 3 square, that's 9, and 12 minus 9 is 3. So v of x value is 3. Okay, that's there. Now, this was a very elementary way of solving the entire question, and let me take you to an advanced way. So, the advanced way of solving would be like this. So, I'll give you here the heading, the advanced method. This can be helpful in this kind of problems. Advanced method, or you can call it method number 2. Okay, that I'll give you here. Now let me first recall that we already, if you know what is Laplace transform, so we already know Laplace transform by this time if you have seen my video lectures. So Laplace transform is nothing but Laplace of f of t is integration 0 to infinity e raised to minus st into f of t dt, right? That's what is the definition. Now when we have over here the thing of Laplace transform of f of t, instead of f of t I'll put t to the power n, then I have 0 to infinity e raised to minus st into t to the power n dt. Okay, and now what we can do, if we change the variable from t, if you go to x, okay, you just replace the variable, do this replacement, replace it by x. So what you see is, or on the left hand side rather, you can even write the formula. Laplace of t to the power n is gamma n plus 1 upon s to the power n plus 1. That is the formula. So if you now see 0 to infinity e raised to minus st t to the power n dt is in front of you. So what is important here is that now if you replace t by x, okay, now you can do, then the formula that we are having in our um, uh, PDF is essentially the same, that e raised to x s minus s into x and x raised to n dx. And if you take up the value over here, gamma n plus 1 over s raised to n plus 1, and if you consider this as 0 to infinity e raised to minus sx and x raised to n dx, then you can barge into a good number of solving of questions in a very easy manner. So in our case over here, what is happened is, in our case s is equals to 1. Okay, so s is equals to 1, so what we get here, a nice good formula of gamma function that we will get is gamma of n plus 1 is integration 0 to infinity e raised to minus x into x raised to n dx. Now the whole solving becomes very easy if one understands here. So the whole solving of the question becomes very very easy if one really understands the whole process. That now see, let's see the example, that when we had to do the integration of e of x, okay, we had here 0 to infinity x into f of x dx. Now here what happens is 0 to infinity x into half into x square into e raised to minus x dx. That's the PDF that we had, right? So yeah, we had this part here. So now when we see this, your half would stand out, and integration 0 to infinity x cube e raised to minus x dx. Now this is nothing but gamma, right? So the integral is nothing but gamma function here, half into gamma of 3 plus 1. And if you know that gamma of n plus 1 is and here 3 is gamma 4, right? Here it's gamma 4, so that's gonna be 3 factorial divided by 2. So that's obviously 3. 3 factorial is 6, and 6 divided by 2 is 3. So that's a very good thing. You have saved yourself from solving that complicated integral, and your steps have reduced. Just a bit of new two formulas you need to know. Now another example of this again, e of x square. Now if you see that previously that e of x square was going a bit lengthy. So if you have half into 0 to infinity x raised to 4 e raised to minus x dx, you'll go crazy solving the integration, because if you do not know the integration formula, then it's a bit tough thing, and it can lead you to a bit of confusion between minus plus signs during integration and derivatives that you are calculating. So half times when you do here, it's going to give you gamma phi, right? So if you compare it with the integration that we just wrote, then it's gamma phi over here, and um, so it's gonna give you half times gamma phi is nothing but 4 factorial, which is 24 divided by 2, and that's going to be 12. See, a very simple way of solving the whole process. So I hope this thing helps you, and you will be able to understand the whole concept easily. Thank you for joining in, and please hit like button and share it with your friends, those who find it useful, and please leave your feedback in the comment section below. Okay, and I would be happy to guide you on any other video of probability. I'll soon see you with other videos on probability. Till then, keep solving good amount of mathematics. I'll join you with you soon.